Hi, my name is Marin Rose, MSc Applied Statistics and Data Analytics student at CB.P2ASD22014. My topic is vector spaces. So the collection of vectors is known as vector spaces. And if you want to describe vector spaces on a plane, if we describe it as the pair of number of x coordinate and y coordinate. And we assume that the tail of the vectors lies on the origin, whereas the head lies on the coordinates. And we discuss this for the two-dimensional vector space here now. So we know that the addition of two vectors gives a third vector, and also multiplication of this vector by any real number gives a vector with a scale. And if you want to generalize this with n-dimensional space, we consider the forces that describes vectors with n coordinates and collectively known as n space. Now moving on to the properties of vector spaces, the first property of vector space is that the addition of two vector spaces is also a vector. That is, if v and w are two vectors, the addition v plus u is also a vector. And the second property is that if two vectors are added, the order of adding these vectors doesn't matter. That is, v plus u equal to u plus v. And the third property is that there exists a zero element in such a way that the addition of this zero vector to this vector doesn't change it. That is, it remains unchanged. That is, zero vector is the identity element. And the fourth property is that for all vectors there exists a vector in the opposite direction in such a way that adding these two vectors gives a zero vector. And the last property is that the addition of vectors follows associative property. And by all this collectively we can tell that vectors form a commutative group under addition, and scalar multiplication follows associative property, and multiplying a scalar with vectors also follows distributive property. And if we multiply a vector with any real number 1, it remains unchanged. Now moving on to the algebraic definition of vector spaces, we have a commutative group which contains elements called vectors, and we have a field containing scalars, and the multiplication of any vectors from the group to any scalar of the field, we get a vector there. This follows the properties of distribution and associative property. And also when we multiply this vector with any real number 1, we get it unchanged. That means it remains unchanged. And this vector spaces have so many real life applications where velocity and forces are needed. For an example, rowing a boat across a river uses the application of vector spaces there. So I conclude. Thank you guys. Thank you.